Use the discriminant to determine the number and type of solutions for each equation. The discriminant is this b squared minus 4 times a times c part of the quadratic formula. That is, this is the part that's underneath the square root. So in general, our solutions for a quadratic, when we're using the quadratic formula, are this negative b plus or minus square root of the discriminant, b squared minus 4 times a times c, all over 2a. Since this discriminant part, the part under the square root, is the part that follows this plus or minus bit, and since it's the part that's underneath the square root symbol, a lot of information about the type of solutions we have depend on whether or not this number is positive, negative, or zero. Further, it also depends on whether it's a perfect square or not. That is, if we can do the square root nicely. So depending on what happens with those considerations, it's going to tell us if we have 0, 1, or 2 solutions to this equation, or to the quadratic equation. So let's go ahead and look at the discriminant for this problem, part A. We have an A here, a B, and a C. So our discriminant, b squared minus 4 times a times c. Our discriminant is going to be negative, or b squared, 16, minus 4 times a, 3, times c, minus 3. All right, so let's compute this real quick. Do the arithmetic. I have minus a negative, so it's going to be plus. 3 times 3 is 9. 9 times 4 is 36. 16 plus 36, that gives us a 52. So we're going to have a 52 sitting underneath our square root symbol. Now 52 is not a perfect square. All right, 52 is 13 times 4, or 13 times 2 times 2. So we could pull the 2 part out, but there's going to be a square root of 13 involved. So we're not going to get a rational number because we have that square root in there. It's not going to be a complex answer because 52 is positive, so I don't have a negative under the square root. And sometimes I'll be adding that thing and sometimes I'll be subtracting it. So I'm going to be getting 2 very different answers. So I'm going to get 2 real number solutions when I compute this answer. All right. Or if I were to compute this answer, because we're not going to compute it. If computing would be easy, plug it in, but we just were interested in the number and type of solutions. So 2 real number solutions on that one. Part B, again, we want to just look at the discriminant, but first we have to figure out what B is, what A is, and what C is. All right, and this is not in the right form, so we're going to have to multiply M through, distribute the M, give us a 2M squared minus 3M. We're going to have to subtract 20 from both sides. Now we have A, B, and C sitting right there. So when I look at our discriminant, b squared, negative 3 squared is 9, minus 4 times A, which is 2, times C, which is negative 20. Here's what we have. Again, negative and negative, so this is going to be plus. So we're going to have a positive number into the square root. I know that already. 2 times 20 is 40, and 4 times 40 is 160. So this is going to be 9 plus 160. That is 169, which you may recognize as 13 squared. So underneath the square root, we're going to be having a perfect square of something. That means that the square root and the square can cancel, and I'm just going to be left with a 13. So I'm going to have minus b plus 13, or minus b minus 13, all over some stuff. B, a nice integer. A nice integer. So when I take an integer plus or minus that 13, I'm going to get another integer. I divide by some integer. The result's a rational number. And I'm going to give 2 different rational numbers. One where I added 13, one where I subtracted the 13. So here, I'm going to get 2 solutions again, and this time they're going to be rational solutions. 2 rational solutions. Again, they are real number solutions, just like they were last time, but we also know a little bit more. They happen to be rational solutions. So this is the number and type of solutions we get for either of these 2 cases.